So we continue the detailed study of discrete time systems. I have specifically chosen the different path because this is something which can be very easily understood by everybody, and then we can correlate the things with continuous time systems. So the approach which I am adopting is not a classical approach, is an approach which is somewhat easier to understand, and as I repeat, if you want some very classical understanding, already I have given to you the lecture sequence, all videos of Professor Gadre for part 1. So those videos you can watch anytime. That is the Bible of signals and systems. So everything is covered in that. The purpose of our sessions, these recorded YouTube sessions which I am putting on the WhatsApp group, is to make you aware of all dense concepts by converting them into simple language, simple lookout, right? So when we say discrete time systems consist of an input sequence xn, which is the sampled version of some physical phenomenon, or which can be hypothetical also. Now, as a sequence, you can generate any sequence. Input sequence xn, it goes through a system where what is a system? System is also a sequence which I can say hk or hn also. Index can be anything, k is there or n is there, not so important. So input sequence xn, system sequence hk, and output sequence yn. So this I can call as hn also. So input, system and output all are sequences. Input, system and output all are sequences, and this, so what is system? A sequence which describes how system acts on current and previous inputs is the system. What is system? System is the manner in which current and past inputs are combined to generate current output. And this Hn is also called as transfer function. Transfer function. This Hn is also called as transfer function. So I am trying my level best to simplify the contents. Contents are otherwise available to you on Google, and also those are obviously available to you on in the videos which I share of Professor Gadre. So I am trying to make it simple. I am trying to decompose it to bring it to your understanding level. And then n starts from 0 onwards. N can be negative also, but we start at, there is no bar that index can't be negative, but unless otherwise it is specifically required, we assume that n starts from 0 onwards. And then if it is a real-time system, it starts at some point. You have a system, you give input, and once it starts, you can continue as you want. So n can start from 0 and tend to infinity, is an integer. Current sample, next sample, next sample, next sample, and so on. Same is the case with the output. And then what is the biggest advantage of discrete time? Why this branch, the discrete times and its handling in digital systems or digital signal processing is important, is because just by changing the program you can change the system. Had it been a continuous system consisting of actual resistor and capacitors, for even small change you have to change the components all the circuit. Now what has happened that exactly sampling theorem, what is its significance, all that we shall discuss later. Similarly, transforms in this subject is very classical. Fourier transform, Laplace transform, discrete time Fourier transform and Z transform. So 4 transforms are there, and I think these transforms cover modules. Maybe some are full modules, some are half modules. But I am trying to expose this subject in front of you in a simple manner where you should feel that you are understanding. You should appreciate each and every point which is being heard by you, and you must be able to find its meaning on your own. That is important. So from that point of view, what is it I want? To give you a simple example, how digital systems have invaded the entire what we can say world itself. Maybe just I am giving an example. Maybe 3-4 decades back, good quality music systems were there. That time this digital has not invaded the entertainment world. In good quality music systems, in normal music system you have controls bass and treble, and so low frequency and high frequency contents are suitably modified. Actually I will be dealing separately on that concept when the concept of frequency response comes, but let us assume that you already know all these things, at least to a pseudo level. Then good quality music systems contain 5-band equalizer, 7-band equalizer, 11-band equalizer. What kind of mixing of different frequency components in a scaled manner is to be done, and for that purpose very complex analog circuits were required to be designed. But now what has happened? Now any kind of spatial processing in analog or signal processing in analog systems has totally disappeared. What is to be done? The world is analog. So I speak, it is recorded, it's a continuous signal. I listen, I speak, it is recorded through mic, it's a continuous signal. I listen through speaker, it is a continuous signal. But everything between mic to speaker is digital. I speak, mic converts my pressure signal into voltage signal, speaker converts voltage signal to speech signal. Mic, speech or pressure signal to voltage signal, speaker, voltage signal to pressure signal, which is speech. So mic gives continuous voltage output, speaker needs continuous voltage input. But everything between these two, after mic, it is some kind of a signal conditioning using a small amplifier, then ADC, entire digital processing, and its output DAC to speaker. DAC to one amplifier and speaker. So what has happened now? Continuously sample input signal, store it, process it, deliver it. It's real time, means continuous analog to digital converter is continuously dumping digital data into computer memory. You have a computer program which takes these data stream, mixes it in an appropriate manner and delivers it, puts it into other memory block, and there is another program which takes up those bytes, puts them on DAC, and the discussion issues which were there 4 decades back when digital was being implemented. That number one is that if I don't have good quality ADC, what is the effect of finite word length and what is the effect of poor sampling? Means those days it was not possible to sample at sufficient rate, so whether that will have some impact, and I will not be able to convert into digital signal from analog to digital. 8-bit ADCs were built, but now 32-bit ADCs, 64-bit ADCs and sampling at some megahertz rate is quite easy. So the effect of sampling error and quantization error is just negligible. We ignore that with this now. So everything is digital, and in digital, this when you want to change system, just change the equation. So xn is the input sequence, hn is the system sequence or system transfer function, y the output sequence, and yn is equal to summation n equal to, since both are required, k equal to 0 to m, where m can be finite or infinite, hk x of n minus k. So I am trying to repeat it to such an extent that even if you decide, you should not be able to forget. Output sequence of a system. What is system? A system gets inputs. Now the subject name of the system is signals and systems, but when we talk of discrete things, the signal becomes a sequence. So what I very precisely, then I am just telling you what is the important sequence. What is the name of the subject? Signals and systems. When we come to discrete, the signal become a sequence and system also becomes a sequence. So there is an input sequence which is sampled from a real-time variable. There is system description which is also a sequence, and what is working of system? System works. What is system? It takes the input sequence, manipulates it appropriately with system sequence and generates an output sequence. An output sequence while generated by a very specific manner by both sequences together. So the output is weighted sum of current and previous inputs. Listen very carefully. Output sequence yn is weighted sum of current and previous samples of input sequence xn, and the weights which multiply current and previous samples in a given manner is also a sequence. What is HK? HK or HN? It is the proportion with which the input sample received K samples ago is contributing in the current output sample. Right? So, if